So we've been doing t-tests so far. What we're going to be doing is doing now paired samples t-tests in all the programs. So in order to do that, we're going to start in Excel. So we'll start off by loading up our paired tdata.xlsx. So if I open up that file, I should get a file that looks like this. And we're just looking at, in this column, body temperature pre-run and body temperature post-run, and seeing if there's a difference. Once we've done that, you can try doing the same thing on skin temperature, pre-run versus post-run. So this, remember, each individual row is a separate subject. So in this case, we've got 11 different rows. If you look up right here where this A6 is, and I scroll down, it actually counts up the number of rows. And I can see that there's 11 rows, which means there's 11 subjects worth of data. Now remember, in order to get our values that we need mean 1, mean 2, and we need to calculate the standard error of the difference. Standard error of the difference being calculated from standard error of mean 1, and then a correlation coefficient multiplied by the standard errors. So we'll go into all of that. I'm going to do this all as one big equation though this time. So the first thing I'll do is get our mean for each of these values. So equals average of those, and pull that over, equals standard deviation of those, pull that over. And our standard error, which is standard deviation divided by the square root of n, which I know is 11. And pull that over. Okay, now the thing that I need is a correlation coefficient between the two measures. Now, I can do that by using a function called correl, equals C-O-R-R-E-L. And we see that its arguments that it needs are just array 1 and array 2. So I'm going to get a correlation coefficient of those values, comma, these values. Close bracket and enter. And we see that we get a correlation coefficient of 0.83. And that's going to be this R in our equation down here. Now I'm going to calculate this all as one big equation. So remember to use our brackets wisely. So I'm going to calculate this, equals mean 1 minus mean 2. But I'm going to put brackets around those, because I'm going to be dividing that by a bunch of other things. And that is going to be the square root of standard error of the mean 1 plus standard error of the mean 2 squared minus all of this. So I'm going to put each of these terms in their own brackets, the things between the plus and the minus signs. So in its own bracket, standard error of the mean 1 to the power of 2 plus, in its own bracket, standard error of the mean 2 to the power of 2 minus, in its own set of brackets, that's this part now, 2 times R, which is our correlation coefficient, times standard error of the mean 1 times standard error of the mean 2. Close brackets, and then one more close brackets to close out both that whole set of the square root. So you can look at that equation, you can write it down, pause it, and make sure you get it right. I'm going to hit enter, and I get a value of negative 19. Again, from what we know, that should be highly significant. Now, of course, we can do that using our t-test function in Excel, which is equals t-test array 1, comma, array 2, comma, how many tails do we want? 1 or 2. I'm going to select 2 tails, comma, what type is this? Now it's a paired, so it is 1 is my type. Close brackets, hit enter, and what we see is we get a p-value of 3.16 times 10 to the negative 9, which is a lot of zeros now before we get to the 3. And if we want, and we only did the t-test and we want to calculate what our t-ratio is, remember we can use TINV equals TINV, and our arguments are probability, so I can just click on our probability, which is for our t-test, and our degrees of freedom. And remember, our degrees of freedom is our number of subjects minus 1, or that is the same as the number of pairs minus 1. And remember, I had 11 subjects, or 11 sets that I'm comparing. Therefore, 11 minus 1 will give me a degrees of freedom of 10. And what we see is that I get a number that's exactly the same, negative 19.219, etc., etc. Okay, so we're going to move on, and we'll do this in SPSS next. And we'll start off by opening up our file called pairedtdata.sav. Now, if I just double click on that, it will open up SPSS. Okay, so what we see is the same set of data up here. Now, in order to do a paired t-test, it's very similar to what we did for the independent samples t-test. We simply go up to the Analyze menu, click on Compare Means, scroll down over to Paired Samples t-test, right? So remember, under Compare Means, we have one sampled, independent samples, but we also have Paired Samples t-test. So I'm going to click on that. And it gives me a window that looks like this. It asks for pair 1, variable 1, and variable 2. So I'm going to click on pair 1. Variable 1 is T-body, or body temperature pre, and our variable 2 is body temperature post, and we'll leave it at that. Now, I'm going to just click on options to see what options I have. And this one is just asking about excluding cases, what happens if I'm missing one set of data, and I'm not going to worry about that because I don't have any missing data. So I'm going to hit continue and hit OK. Now what we see in our output is our paired sampled statistics. We see our means for our pre and post body temperature, our N, our standard deviations, and our means. Then we see the correlation coefficient that we calculated in Excel just a moment ago. And then we see our output of our t-test. I will scroll up, put a little bit higher here. And what we see is our pair 1 is our body temperature pre and post, and here's our means. And what we see is, what we care about here is our t-ratio, which is negative 19.219, our degrees of freedom, which is 10, and we see that we've got significance, a two-tailed significance of 0, 0, 0. Now, you don't typically report 0, 0, 0 because it's never exactly 0. It's just less than 0, 0, 1. In fact, we can double-click on this value to see exactly what it is. So if I double-click on that value, it opens up another window with just that test, and I can click on this, and we can see that it is 3.165 times 10 to the negative 9. Again, that's the same value we just saw in Excel. Let's do this same test in JASP. We're going to open up our file called pairedtdata.csv in JASP. So I'll just open up that file. paireddata.csv, open. And remember from last time we had an option along the top to select t-tests, and I'm going to select paired samples t-test this time. Now, it asks for variable pairs, so I'm just going to select both pre and post just by holding the shift down, but I can just put it in there and select that. And what it does is it simply outputs that immediately. Again, we can select a few different options if we want. We can determine whether these are not equal. This will give us one-tailed. Is measure 1 greater than measure 2, or measure 1 less than measure 2? That is one-tailed tests. We can do assumption checks, etc. But what we see is here we've got our t-ratio, our degrees of freedom, and our p-value being less than 0.001, which matches up with what we've seen so far with all the other tests. Okay, lastly, let's do this same test in R. All right, so let's do this in R now. So I'm going to open up RStudio, and then I'm going to open up the paired t.csv into a new data frame. So again, I need to go up and import a data set from text, and I'll open up that file that I need. And I'm just going to call it paired t. Does it have headings? Yes. Import. We see our data set. It looks good here. Okay, back to our script. And what I'm going to do is use the same thing I did last time, copy and paste it. Again, we've already learned how to do our descriptive statistics, so I'm not even going to worry about that this time. And I'm going to need to attach the correct data frame, which is paired t, and then we're going to run just the t-test function, t.test, and this time I need to figure out what are the variables that I'm going to be comparing. So in paired t, if I look at it, it's tbody underscore pre, and take note of the capitals. There's a capital T and a capital P, and tbody post. Those are my two variables that I'm going to compare. The way I do this is say t-test, t body underscore capital pre, comma, tbody underscore post. Then I need to add another argument, which is paired equals true. And that will give me my paired t-test. And if I select all of that and run it, we see it comes up with an error. Error, object paired t not found. Yes, clearly, because that's not an object. It's paired. I spelled it wrong. P-A-I-R-E-D. Okay, let's run it again. Run. Okay, so we see this time, happily, I get my paired t-test. Paired t-test gives my t-ratio, 19.219. That's what we've seen before. Degrees of freedom of 10. And it gives us our p-value of 3.166 times 10 to the negative 9. And it gives us our 95% confidence intervals of the difference and the mean of the differences. So that's all we really need to know in order to be able to do our paired t-tests. So what I'd like you to do is go ahead and open up that file in the other programs again, but this time do the calculations on skin temperature instead of whole body temperature, and see if you are getting the same numbers across all the different programs. That'll give you a little bit more practice in doing paired samples t-tests. All right, hopefully that's helpful for you.